Right, so welcome back. Today we're going to do two things. First is sine and cosine relationship. This is very short and simple. And then solving trigonometric equations. Okay, so I'll give you an equation. For example, sine 2x equals to 1 over 2. Okay, then what you normally do is, okay, 2x is then, I think you would have seen this before. This is the inverse, right? The inverse of sine, right? Okay, so you'll do this, then you find this out in the calculator. You will get 30 degrees. Okay, so you will say x is 15 degrees. But remember we did four quadrants, and so you have, if this is 30 degrees, okay, here the sign will be positive, so this is sine 30 degrees is 1 over 2. But at the same time, if this is 30, okay, then how about this angle? So this will be 150, right? 180 minus 30. And what is the sine of this angle? So sine 150. Okay, so if you remember from the last video, we said that this is in quadrant 2, 2, okay? This is quadrant 1, right? So in quadrant 2, the angle will have positive sign, and the sine of this angle, okay, will be equal to sine 180 minus 30, right? This 150 is 180 minus 30. And if you recall, sine 180 minus theta is equal to sine theta, okay, for any angle theta. So see, this will be sine 30, which is 102. So then this 150 here can also be 2x, right? So if we take 2x equals to 150 and not 30, okay, first we took for the 30 case. If now you take the 150 case, x can also be 75. So you have two answers. X can be 15, x can be 75. Okay, so you're going to do this kind of question later. All right. Okay. Now, first let's go to the sine cosine relationship. I don't want to spend too much time on this. Okay, it's very short and simple. Okay, let me tell you the result before I prove it to you. So the result will be, if you have an angle theta, okay, so sine theta is the same as, so sine theta will have the same value as the cosine of 90 minus theta, and the opposite is also the same. Okay, cosine theta is equal to sine 90 minus theta. This is the relationship. All right. This is true for any angle theta, okay, but for now I will prove the first quadrant, or let me just say the right angle triangle case. Okay, all right, so now let me draw a right angle triangle. Okay, okay, this triangle doesn't look very nice, but it's okay. So then we know, okay, this is our right angle, so this is 90 degrees. Okay, so I'm going to do two things. So I'll use two colors. Okay, so first is our blue angle. This angle is theta. Okay, so for theta, we know what the opposite is. So this is the opposite, this is the adjacent, this is the hypotenuse. Alright, notice I wrote everything in blue color. Okay, because this is only for the angle theta. There is another angle inside the triangle, and that is should I use orange. Okay, so there's this angle. Okay, and what is the value of this angle? We know that triangle has a total of 180 degrees. Okay, so one of it is 90, the other one is theta, right? So what is the third one? You just take 180 minus 90 minus theta, and this gives you 90 minus theta. Alright, so this angle here is 90 degrees minus theta. Okay, so now we have a blue angle and an orange angle. So for the orange angle, first, where is the hypotenuse? So the hypotenuse doesn't change. Okay, the hypotenuse is still the same line. This is still the hypotenuse, this thing here. Okay, the hypotenuse for the blue and the orange angle is the same. Hypotenuse is the longest line of the triangle. But how about opposite and adjacent? So for this orange angle here, the opposite should be this line. Okay, and then the adjacent should be this vertical line here. So this is the adjacent. So notice, for the blue line and for the blue angle and the orange angle, the opposite and adjacent is like terbalik. Okay, it's inverted, meaning for the opposite for the blue is the adjacent for the orange. The opposite for the orange is the adjacent for the blue. And this is why we have the relationship on the, oops, what is all this? Oh no, let me just write all of this again. Okay, so then let's try writing. So I'll write in blue also. What is sine theta and cosine of theta? So the blue angle, this is O over H, A over H. Okay, but we know that, so we can find what is sine 90 minus theta and cos 90 minus theta. Oops. Okay, so sine 90 minus theta is the orange over H, the cosine is the orange A over H. Okay, but what is the orange O over H in terms of the blue lines? Okay, so the orange O is the same as the blue A. So let's write a blue A here. And then the H is the same. Okay, so same thing for cosine, the orange A, right? This thing here. Okay, the orange A is the same as the blue O. So we write O over H. So now you notice that cosine of theta is the same as sine 90 over theta. This is A over H, this is A over H. Okay, similarly, the sine of theta over H is the same as the cos of 90 minus theta, which is over H also. And that's why we get sine theta equals to cos 90 over minus theta, cos theta equals to sine 90 minus theta. Alright, so this is only for the right angle triangle case, meaning this theta here is between 0 and 0 degrees and 90 degrees. But it, in fact, this is true for this relationship here is is true for any angle theta. So theta can be more than 90 degrees. It can be 150, it can be -5, it can be anything. Okay, it's still the same relationship. All right. Okay, so you can do some trial and error and verify this thing for yourself, but I will move to solving trigonometric equations for the next 10 minutes. Okay, so just now I showed you how you take this angle 30. Okay, if this is also 30, I mean this is not very accurate, but okay, never mind. Okay, so if that is 30, then what is this angle? So this angle is 150, and we said that sine 150 is basically sine 180 minus 30. Okay, and so this is equal to sine 30, right? Because of what we did in the last class. Okay, so this is the second quadrant, this is the first quadrant. All right, sine is positive, so this will be also 1 over 2. So if sine 2x is 1 over 2, okay, it's, so either if you get either this line or this line, like you get this kind of angle or this kind of angle, okay, the two black angles here, any of this will still give you the same answer, 1/2. Okay, so you can get more than one answer, but in fact you can get many answers if you just say that sine 2x is equal to half. Okay, so let me use a purple color line. Now one circle is 360 degrees. Now if I go one circle, so look at the purple line, I go one circle, okay, and then I add another 30 degrees. So that is, this is 360 plus 30, so this is 390 degrees. You get back the same line here, right? The purple line now. So this is the same as, so this sine 390 is the same as sine 30. Okay, so pretty much for any angle theta, okay, sine theta is the same as sine 360 plus theta. Okay, cos theta is the same as cos 360 plus theta. Okay, so this is another thing that we need to take care of. Okay, and if I go 2 rounds, it's also the same. So I can, maybe I don't go, oops, so maybe I don't go 1 round, I go like 2 rounds. Okay, so look at the right angle. I go 1 round, I go another round, and then I come back to the same line. So 1 round is 360. Okay, and then another round is another 360, and then I go an extra 30 degrees. So this is, you add another 30 degrees, so this is total 750 degrees. All right, so sine of 750 is also sine of 30, which is 1 over 2. So this 2x here can be a lot of numbers. Okay, you can go as many rounds as you want, right? So this 2x can be 30, can be 150, it can be 390, can be 750, it can be a lot of things. So we cannot go like, okay, I can do 100 rounds or so and then I get another answer. So you know, this is not the right, I mean, you don't want to write hundreds of answers on your exam paper. So what they'll normally do is, they will say maybe sine 2x equals to 1 over 2. Okay, and they'll give you a range. So they will say Okay, we only want answers x between 0 and maybe 180 degrees. Okay, or maybe 0 and 300. I mean, depends, whatever they can give you, whatever they want. Okay, 0 and 360 degrees, or they can even give you maybe say okay, negative 180 and positive 360. They can give you, they'll give you a range, so your answers must all be within the range. So let's say 0 and 180 degrees. All right, to make this example simpler. Okay, so okay, now, so step 1 to solving this kind of equation is find the range for the function inside. So I'll say this inside. Okay, what this inside means is, so I have sine 2x equals to 1 over 2. That's a equation. So basically I'm not doing sine x, right? I'm in fact multiplying x by 2, and then so I'm multiplying x by 2 first, only then I apply the sine to it. So this is sine 2x in bracket. So find the range of 2x. So in this case, in our case, find range for 2x. So if x is between 0 and 180, that means 2x should be between 0 and 360. Okay, so now this is what you want. Okay, you want to do it for 2x first. You can find what 2x is, then divide by 2 and get x. Okay, so to find what 2x is, you need to know what are all the possible angles that you can get. So now we are taking 2x between 0 and 360. All right, then step 2, find so step 2, I would say, okay, find the reference angle, or in some places they call this basic angle. Okay, and basic angle, easy to write it as alpha. Okay, so what is the basic angle? Remember just now I said if you have sine, so sine theta equals to over 2. Okay, for example, what you'll do, you'll say theta equals to inverse of this, right? And then you will get, if you put it in a calculator, you will get 60. Okay, so this is the basic angle. Basically this theta here, 60 degrees, is the basic angle. Okay, point is, in your calculator you will only get 60 degrees. Okay, you won't get other numbers, you won't get 100, like, so you know that in our case, what is shift sine of 1 over 2? If you put in your calculator, it will give you 30 degrees. All right, so 30 degrees, the point is, this is not a complete answer. Okay, this is the basic angle or the reference angle, so this thing here. Okay, oops, so what I'm saying is, find this basic angle first. So we can call this angle alpha. Okay, alpha. How to find the basic angle? Apply inverse trigonometric function. So if it is sine, then you apply sine inverse, you find it on your calculator. Alright, or you can, if it's an easy angle, you don't need to use a calculator. Like 1 over 2, you know it's 30. Okay, so alpha equals to sine half, which is 30. So this is your basic angle. Okay, third step. So you know alpha equals to 30 degrees. Okay, this is the basic. Alright, now what you need to do is find all possible angles. Okay, so here what we do is, there are two things that you need to do. One, use the range for the inside function, meaning now is where you use this 2x being between 360, right? Now is where you use this information. Okay, so you know 2x is between 0 and 360, so you can even for the starting stages you can draw a Cartesian plane and then say, okay, where do I want? So this 2x, okay, we are looking at anything in the, so any angle in the in any quadrant can work, as long as it's just one round lah. So I cannot go 2 rounds, I cannot go 3 rounds, and also and so on. Okay, and I'm not taking the negative angle, so I'm not going in this direction. Okay, I'm only taking angles that are positive and less than 360. Okay, cool. So you already know this. Now, so now 10 is determine quadrant. Okay, so we know that sine 2x is 1 over 2. This is positive. So if it's a positive sign, where must it be? It can only be in quadrant 1 or quadrant 2. Okay, so not this side. So this side is already no more. Okay, only quadrant 1 and quadrant 2 in our case. Alright, okay, so we have quadrant 1 and quadrant 2. Okay, so we know this is 1 and 2. Third, find the angles. Okay, so what is the quadrant 1 angle? So the quadrant 1 angle is just the basic angle. So quadrant 1, 2x is just 30. Okay, basically 2x is just alpha. Okay, so then x is 15, not 150, sorry, 15. This is degree. Okay, cool. Quad 2, how do you do? 2x equals to, so what is the quadrant 2 angle for this? So oops, oh my god, better just delete this thing. Okay, what is the quadrant 2 angle for this? So remember, if this is alpha, in quadrant 2 what angle we are interested in is, so this also must be alpha. So now we are interested in this right angle here. And what is the right angle? It's 180 minus alpha. Oops. 180 minus alpha. So this is the quadrant 2 angle is 180 minus alpha, meaning 180 minus 30. This is 150. So then x is 150. If 2x is 150, then x is 75. Alright. So our final angles are x is 15 and 75. You write it like this. Okay. Alright. So I think this is the end of this video. In the next video, so if you have any more questions about this particular thing, questions like this, there can be many different kinds of questions like this. So if you want to ask about these kinds of questions, leave your questions in the comment section. I will also be providing some practices, but you do go back to your workbook, buku latihan, whatever. Go and try and do all these questions. Okay, solving trigonometric equations, try to do, because there can be a lot of examples. So if you do a lot, you will get fast at it. All right, see you. Maybe in the next video we can talk about this a bit. Okay, bye.